All right, everyone. In this video, we're going to go over some layer 2 switching fundamentals. So in the past two videos of our layer 2 section, we've gone over layer 2 at a kind of a high level overview, right? What is the Ethernet frame? What is the MAC LLC sublayer? Some other definitions and terms. So now we're actually going to get into switching. So now we're going to bring the perspective of you actually are working on a Cisco switch. Let me bring my pen out. And this Cisco switch has endpoints connected to it. And we're going to now go over exactly how these endpoints, let's say this computer A, computer B, are going to talk to each other via layer 2 by sending frames, and how the switch actually logically forwards these frames, okay? So let's jump right into it. So first, we're going to go over switches versus hubs. And we kind of went over this in our last video. So if you're watching this chronologically, you can probably skip this. But in the days of old, before we had these logical switches that actually had a brain to them, right? We had hubs, which were layer 1 devices that would simply just send Ethernet frames out all interfaces. And you'd have something called collisions. And this was because there was no media access control, meaning that hub didn't take those Ethernet frames and send them out individual ports or logically forward them. Now with switches, like we've been saying, they're going to use logic and a forwarding table, which is going to be our CAM or our MAC address table, which we're going to get into, to determine how do we switch packets in the LAN, how we actually switch these frames in the LAN. So again, what is the purpose of a switch? So the switch's original purpose was in a local area network was to forward frames and then store the source MAC addresses of all the connected devices into something we call the CAM table. The CAM table stands for Content Addressable Memory. And using this CAM table, the switch would build a logical forwarding table for all the networking nodes connected to the switch. So the CAM table, otherwise known as the MAC address table, would be built from incoming traffic from all the endpoints connected. And then we'd build almost this like Excel spreadsheet where we'd say, hey, on gig 01, we have MAC address AAA connected. And on gig 0/2, we have MAC address BBB connected. So when computer or server B wanted to talk to server A here, it would build its Ethernet frame, right, its header, and it would have the destination to server A, and then its source would be its own MAC address. And when the switch would receive this frame, it would then reference its CAM or MAC address table and say, okay, well, I see the destination in that Ethernet frame header is all A's. And I have that MAC address associated to port 01. So I am going to send this Ethernet frame out port 01. And that's in its simplest form the logic that switches take in forwarding layer 2 traffic. Okay, so switch forwarding. A switch will use source and destination MAC addresses to send layer 2 traffic. Like I kind of already just described, kind of jumped ahead there. A switch will insert a source MAC address into its MAC address table that it's then going to correlate to the port it came in on. And as we see here in our Cisco switches, we can, from privilege mode, execute this command, show MAC address table. And it's going to show you exactly what we just described. The source MAC address of the device, the port it's connected to, and also what VLAN it's a part of, which will become important later when we talk about VLANs. And then we also have the type here, dynamic, which essentially means that, hey, this MAC address table learned about this dynamically from a device, let's say computer A, plugging in to port gig 0/0. Okay, so the CAM table uses the switch's memory. So, or kind of like a computer uses its memory to build any dynamic table like an ARP table. The CAM table uses the switch's memory to build a MAC address table, again, all based on ingress source MAC addresses. And by default, that CAM table is going to have an idle time of 5 minutes for dynamically learned MAC addresses. So what does that mean? Essentially, if we have a computer plugged into this port here, gig 10, and we see it's dynamic, in 5 minutes, if that switch doesn't receive any traffic from that computer, it's going to flush out that entry in the MAC address table, okay? Now, it doesn't mean you need to be like constantly browsing the web. Your computer can just be plugged in as long as it's maintaining an internet connection or a physical connection to that switch. We're going to maintain that entry in the MAC address table. What this is saying is essentially if that computer turns off and there's no actual connection from endpoint to switch, we're going to flush all entries within 5 minutes. So an idle time of 5 minutes for the MAC address table. Okay, so now let's go over switch forwarding when we have a known destination. So what do we mean by that? That means we have plugged in computer A here. We've plugged in computer B into this switch. I'll name it switch 1. And they've already sent traffic to that switch, causing that switch to learn the source of the ingress traffic and associate it with the port. So when computer A wants to talk to computer B, it's going to create that Ethernet header, do that encapsulation that we know, and it's going to have its own source MAC and the destination MAC address to computer B. Once switch 1 receives that frame, it's going to reference its MAC address table, say, okay, I inspected this frame. Let me see where the destination MAC address 33B lives. And if it does have an entry for that MAC address table, for that MAC address in its table, it's going to then forward that frame on to the destination. Pretty simple, right? Kind of easy logic to follow. Well, now what happens if we have an unknown destination MAC address? So let's say we have computer A and computer B here, and computer B is not in the MAC address table. Well, what are we going to do? So when computer A sends that frame out, switch 1 is going to receive it, and it's going to say, whoa, I don't know where that destination MAC address is. So now let's go into what we call the broadcast MAC address and flooding the frame. So what that switch is going to do, it's going to flood a broadcast frame out all active ports. Key thing to know, all active ports except the one it came in on, so it can find the destination. So what it does is it's going to send this broadcast frame out all active ports, right? So if we have ports 0 through 24 and only ports 9, 12, and 16 have computers connected, these are the only ports that are going to receive that broadcast frame. And that broadcast frame, once it reaches the destination, in that payload behind this Ethernet frame is going to say, it's literally going to have a message that says, who is 333B? And then this computer, it's going to see that payload message and say, oh, hey, I'm 333B. So I need to respond to this broadcast frame. Whereas, let's say we had another computer connected here, computer C. When it receives that broadcast frame, it's just going to not respond and drop the traffic, right? And be like, hey, that payload's asking who is 333B. I'm 333C. I don't need to respond to this broadcast. So once computer B then responds to that broadcast frame, the switch can now insert that ingress traffic and that source MAC address into its MAC address table. And now computer A and computer B can now talk to each other. Very important that we understand this. So if I went a little too fast, maybe play me a little slower or go rewatch that, because this will be something that you're testing on in the exam environment. I've had past students come up to me and say, hey, going over the switch forwarding with an unknown destination is very important for the exam. Whew, okay. Now let's take a deep breath, right? And now we're going to go over some forwarding methods, okay? So the first one we're going to talk about is store and forwarding. So this is kind of not talking about how it sends the frame. This is more at the hardware level, what the switch is doing when it's getting all this Ethernet frame traffic, okay? So in store and forwarding switching, when the switch receives a frame, it stores the data and buffers until the complete frame has been received. So during the storage process, the switch analyzes the frame for information about its destination, and it's also going to perform an error check using that Ethernet frame's trailer or that CRC, right? So it's going to compare those values and make sure that there's a match between the original value here and the value here when it reaches the destination. And if it's a match, it's going to go ahead and forward that traffic. So that's called store and forwarding. We also have cut-through switching. And in cut-through switching, the switch is not going to buffer at all. It's just going to act upon the data as soon as it's received, even if the full transmission is not complete. So in cut-through, we're going to locate that destination MAC address, and it immediately start sending out, right? So the switch is not going to perform any error checking on that frame. It's just going to immediately start sending. And when I say immediately, once it receives that destination MAC, as you can see here in this little animation, it quickly checks its MAC address table and says, boom, I got a match, send it out. And that's it. Okay, now we're going to go over some very basic switching concepts. So in this photo, I know it's kind of hard to see, so we'll probably switch that for our redo of this video. But in a catalyst switch, the ones that we're going to be using in our enterprise, this is the front panel of that switch. And we have this little mode button here and these lights that kind of give us information about our switch. So number 1 is the system LED. Number 2 is the RPS LED. And we just have a lot of different information we can see from the front. A couple things like for the real world guys that I've used just by looking at the lights of the switch is if you're doing something like port security, or you think you have like a spanning tree loop, a lot of times if you see an orange light on this port here blinking really fast, that means that port's in some sort of error disabled mode, okay? Also, when you're password resetting a switch, you can hold down this mode button here when you restart the switch, and that'll bring you into Raman mode, right? Where you can then password recover the switch if you forgot your local console password. Okay, and now let's go over the different types of switches. And what we mean by this is we're going to go over the Catalyst line of Cisco switches. And the reason we do that in the CCNA is because this is typically the enterprise model of switches that you're going to be working on. We know Cisco has small business switches. We know they have their Meraki line. But this is going to be the switches that you typically see in enterprise, especially when it comes to a 3-tier. Misspelled that. A 3-tier core topology, which we learned in our first section, right? So remember in our 3-tier core topology, we have access switches, we have distro switches, and we have these core switches. So if you look at just these switches here, it actually tells you that these two in the middle would be commonly used as distribution switches. You can see how heavy duty they are. They got this supervisor chassis up here. And then these 9500 and up Catalyst series would be our core switches. So this is going to be the switches with the most power, right? And then down here, our last two, the 92 and 9300s, these are going to be more for our access switches where we just want to plug in our endpoints and users. Most of the time, our servers are going to be plugged into our distro switches up here too. Now, one thing to note, guys, with these different chassis, these different Catalyst switches, yeah, you can be very to the T in how you deploy these. If Cisco says it's a distro switch, it's a distro switch, right? And you should try to go with Cisco best practice, especially if your company has the money to spend. But let's say you have a 9400 series switch. That can be your core switch as well. It just depends on your architecture and how much internet traffic and user traffic you have, right? Sometimes it's not always best to spend money on a 9600 series if you have a small to mid-sized business with not a lot of growth in its near future, right? And then if a company does exponentially expand, you can always go back to the drawing board and order these core switches to keep up with the expansion, okay? I just like to go over this section and kind of give you an overview of Cisco's current flavor, right, of the Access Distro and Core switches. Okay, now let's go over, switch management. So a switch can be managed in a couple different ways. It can either be managed from a console cable, actually in person, or it can be managed remotely via an SSH or even a telnet session. So as you can see here, we have our computer here from the 90s, and we're using a terminal emulator program, kind of like PuTTY or Secure CRT, which is my personal favorite. And we're using that blue Cisco console cable to plug into the console port down here to actually get into the CLI. And then here we're also using a terminal emulator program. And we can see we're remotely managing our switch. Maybe we're located in Hawaii because we're living out our dreams on the beach. And we're managing a network in New York. We can go and use SSH and tunnel through the internet to reach our switch remotely. And this is going to be making a connection on what we call the VTY lines of that switch. Okay, and then how do we configure remote management for that switch? Well, we're going to use something called SVIs, or a switch virtual interface. And here we just have like a basic configuration of how we configure SVIs on our switch. Again, depending on how your switch or your architecture or really your baseline for your networking shop, a switch is going to need a layer 3 address to be remotely managed. And the way we do that is with SVIs. So on your access switches, you may only see one SVI, and that's just for remote management. And then on your distro switches, you may see hundreds of SVIs because they're going to be what's used for all your layer 3 routing for your internal network, okay? So we're going to dive more into this later on in the next few sections when we go over inter VLAN routing and our VLANs. But as you can see here, to create an SVI, it's real simple. You create the VLAN, you create the layer 3 interface, give it an IP address, turn it on, and boom, now your switch can be remotely managed. Okay, I believe that's it for this section. So I want to thank you guys for viewing. And stay tuned because in our next sections, we're going to start getting into some configuration, the fun stuff. So please stay tuned.